Hi class. So I am so sorry not to be there today, but these are notes for elimination day 2. And I want you guys to start by pausing this video and completing the warm-up problems 1 and 2 right here at the top. You should know how to do these based on our lesson from yesterday. So go ahead and hit pause and solve the 2 warm-up problems. Hopefully you paused, and here are, boom, the answers. So you should have gotten for number 1, 6, -6, and for number 2, -1, -8. So yesterday we learned that when we have 2 variables that have the same number in front but different signs, those cancel. And sometimes they don't cancel so nicely, and we have to change all the signs or subtract one of the equations rather than add. But today we're moving on and we're stepping up our game even more. So what do we do if we do not have a variable that's clearly ready to cancel out? Well, what we're allowed to do is we are allowed to multiply one or more equations. So I'm going to say one or both equations in order to eliminate. Multiply one or both equations in order to eliminate. So the next 2 problems are smashed it problems where we only have to multiply one of the equations in order to eliminate a variable. So what I am going to do right now is look at my x's and my y's and decide which letter might it be easier to eliminate. If I try to eliminate the x's, there's really no number that that 3 can multiply by in order to get the number 2, and there's no number that 2 can multiply by in order to get the number 3. So that might not be my best option, which is why I'm going to look at the y's. And so if that didn't make sense what I just said, here's what I mean. I can take the number 3 and I can multiply it by the number 2, and the answer will be 6. So if I have a scenario like this where I can multiply one of the numbers in order to obtain the other number, then that's the variable I'm going to want to eliminate. Now, the only other thing is that right now both of these are positive, and in order to cancel out, I need one to be positive and one to be negative. So I need to turn this positive 3 into a -6. And I'm going to do that by multiplying this entire equation, not just by 2, because 2 times 3 is 6, but by -2 so that they cancel. And when I do that, I have to distribute the -2 to every single part of the equation, including the 15 on the other side. So here's what I end up getting. -2 times 3x is -6x. -2 times 3y is -6y, and that is going to equal -2 times 15, which is -30. Underneath that, I am just going to rewrite the second equation as is, which is 2x plus 6y equals 22. And notice now my y's are going to be able to cancel out. I have a positive 6y and a -6y, which cancel. So I end up with -4x equals -8. Divide both sides by -4. And we get x equals +2. So that's one of my answers. Now we just have to go back and solve for y. You can plug into either one of these 2 equations, or you could plug back into one of the originals, which is what I suggest to do. I think the first one looks easiest. So that's 3x plus 3y equals 15, but now I know that x is 2. So I plug in 2 for x, and then that gives me 6 plus 3y equals 15. I am going to subtract over the 6. So 3y equals 9. And when I divide both sides by 3, I get y equals 3. Which means my final solution is 2, 3. All right, let's do this again. This next one is smashed it because I have to rearrange it. So let's do that first. I have to rearrange this equation because the x and the y are not on the same side. So in order to do that, I'm going to subtract the x over to the left. And that gives me negative x minus 2y equals 12. Now, underneath that, I was going to rewrite this one. However, let's go ahead and since it's a negative x, well, actually, let's rewrite it. Okay, I'm second guessing myself. Let's do this. Negative x plus 4y equals 12. So what I want to do, which is what I was planning on doing all along, is change all of the signs of one of these two equations. It doesn't matter which one. I'm going to change all the signs of the top one. So both of those negatives become positive, and then the 12 becomes negative. And what this does is it allows me to eliminate the x's now. So then I get 6y equals 0. Which is a little weird. A lot of students want to say no solution here, but this is actually, there is going to be a solution. 0 divided by 6 is 0, and 0 is a numerical answer, so I'm allowed to get it. So y equals 0 is my first answer, and now I'm just going to plug back into one of my original equations to find the other letter x. So let's plug in here. That's negative x plus 4 times 0 equals 12. So that's negative x, 4 times 0 is just 0, equals 12. So x is negative 12. Okay, so my final answer is negative 12, comma 0. All right, so those were the smashed it problems. Now let's get into the mastered it problems, which is where I have to multiply two equations. So in order to eliminate the x's, can I multiply the number 2 in order to equal the number 3? No. Can I multiply the number 3 in order to equal the number 2? No. And the same is false for y's. I cannot multiply 5 by a number to get an answer of 6, and I cannot multiply 6 times a number to get an answer of 5. So this is a scenario where I have to multiply both equations. So this is the trick. I'm going to eliminate my x's. The trick is this. Since the top number is 2 and the bottom number is 3, you can actually just kind of swap that and multiply the top number by 3 and the bottom number by 2. However, in order to cancel these out, I need one of them to end up negative. It does not matter which. So I'm just randomly going to choose to multiply the negative with the 2. So let's go ahead and rewrite these equations with this multiplication. So 3 times 2 is 6x plus 15y equals 33. And for the orange, we're going to distribute. Negative 2 times 3 is negative 6x. So now you can see why I had to do that negative, because those x's will cancel. Minus 12y equals negative 24. Okay, so the 6 x's do cancel. I get 3y equals 9. So I will divide both sides by 3, and I will get y equals 3. All right, now I'm not totally done. I'm going to plug back in to solve for x, and I'm going to plug back into either of the original equations. I think the top one looks easier, so that's going to be 2x plus 5y. But I know that y is 3. So I'm going to plug in 3 for y equals 11. So that's 2x plus 15 equals 11. I'm going to subtract over the 15. So that's 2x equals -4. And then I'm going to divide over the 2. So x equals -2. All right. That means my final answer is x comma y, -2, comma 3. Let's do that again. Let's do it again with number 8. Okay. We're going to multiply both equations so that something cancels. And what I'm noticing about number 8 that's kind of nice is that the x's already have one positive and one negative number. So I don't have to worry about the whole negative thing. If they're opposite signs, that's desirable. So let's multiply this top equation by 2 and the bottom equation by 3. You kind of switch those numbers. So for the top part, the top equation, we're going to distribute the 2, which gives me a -6x. 2 times 4 gives me 8y. Equals 19 times 2 is 38. In the denominator, or not the denominator, the bottom part, bottom equation, 2 times 3 gives me positive 6x plus 9y equals 3 times -7, which is -21. So I'm going to combine these equations together and something should eliminate. The 6's cancel. I get 17y equals 17. And let's divide over 17, so y equals 1. Now we just have to go back and solve for x. I'm going to plug back into one of the original equations. The second one looks easier to me. So that's a 2x plus 3 times 1, which is y, equals -7. So 2x plus 3 equals -7. Subtract over the 3. That gives me 2x equals -10. And divide both sides by 2. So x equals -5. Which gives me my final answer at -5, comma 1. So these are definitely mastered it level. These are A-level problems where you have to multiply 2 equations in order to get something to eliminate. Now, the very last thing I want to point out is special cases. So when is it a no solution versus when is it an IMS? And these are pretty simple problems. Let's start with number 9. You can see right away that boom, boom, boom. Everything cancels. So these special situations happen when all the variables cancel out. And in this case, everything canceled. So there's literally nothing left on the left, which is 0, and nothing left on the right, which is also 0. And it is a true fact that 0 equals 0. So when I end up with a true statement, that's when it's infinitely many solutions, IMS. The second example, let's see, nothing cancels really nicely, so I need to multiply this top equation by 2 in order to get my x's to cancel. So if I multiply the top equation by 2, I'm going to put the answer right down here. I get -2x plus 4y. 2 times 10 is 20. And what this results with is a false statement because notice my x's cancel, so do my y's. So I have nothing left on the left, which is 0. But I have 12 on the right. And 0 is not equal to the number 12. So that is a false statement, which means this is a no solution. Okay, so at this point, those are the notes. We talked about the got it level yesterday and the smashed it level. And then today we talked about the smashed it level again, and we moved on to mastered it. So I need you guys to try it. You're going to try 3 smashed it problems and a mastered it problem, and you'll check your answers. Good luck, and I'll see you tomorrow.